So in this lecture we are going to discuss about the periodic table. Now there are total 118 elements are known, and it is difficult to study physical and chemical properties of each and every element individually. Okay, and to resolve this problem, these elements are arranged in groups and periods so that elements having similar properties belong to the same group. Now next, maximum number of elements that can be accommodated in modern periodic table are 118 elements. Okay, 118 elements can be accommodated in modern periodic table. Now you don't have to remember all the elements that are present in the periodic table. Okay, you just have to remember some of the groups, okay, that will help you to understand the upcoming chemistry. Okay, next, so in this periodic table we have total 18 groups. Okay, so groups, there are 18 groups, and periods we have 7 periods. Now these 18 groups, in Roman number we have 8 groups. Okay, and these 8 groups in Roman number are divided into subgroups, that is A and B. Okay, now here the first group we have is this is the first group, this is second group, third group, fourth group. Okay, this is fifth, sixth, 7, 8, 9, 10, 11, 12. Okay, next 13, 14, 15, 16, 17 and 18. Okay, so these are the 18 groups in the periodic table. Okay, now next, in Roman number we have the first group is called as first A. Okay, this is the first A, this is second A. Okay, now this is third A, this is fourth A, fifth A, sixth A and seventh A. Okay, and this 18 group is called as zero group. Now this 11th group is called as first B. Okay, in Roman numbers. This 12th group called as second B. Okay, this third group is third B, fourth B. Okay, fifth B, sixth B, and these 7, 8, sorry, okay, this is 7th A, sorry, 7th B. Now this 8, 9, 10, these three groups are included in 8. Okay, so these are the 8 groups in Roman numbers. Okay, now so this is about the periodic table. Now you have to remember the first group, first A group, second A group. Next, this is this 13 group, 14, 15, 16, 17 and 18. These groups you have to remember. Okay, these groups and the elements that are present in these groups you have to remember. Next, what you have to remember, this whole, okay, this from scandium to zinc. Okay, these elements you have to remember. Next, below zinc we have cadmium and mercury. This is below copper we have gold, sorry, silver and gold. Below nickel we have palladium and platinum. Okay, these many elements you have to remember. Okay, next we are going to discuss about each and every group here. Okay, so let's start with the first group, that is first A. Okay, so this is the first A group: hydrogen, lithium, sodium, okay, potassium, rubidium and cesium. Okay, so this is called as first A group. Okay, this group is called as alkali metals. What is the name of this group? Alkali metals. Okay, now this hydrogen is non-metal. This is non-metal. Now, due to uncertainty in the position of hydrogen, hydrogen is called as notorious element. Okay, notorious element. Notorious element. Next, all these first A group elements have one electron in their valence shell. Okay, one electron in their valence shell, and that's why all these first A group elements like to form ions with +1 positive charge. Okay, so they form ions with +1 charges like this. Okay, so this is about the first A group. Okay, and next, these alkali metals are, okay, these alkali metals are most reactive metals, most reactive metals in the periodic table. Okay, now this is cesium, and the last element we have is the francium. Okay, so here the francium is the most reactive metal in whole periodic table. Most reactive metal in periodic table. Most reactive metal in periodic table. Okay, so this is about the first A group. Next we have second A group, that is beryllium, magnesium, okay, calcium, strontium, barium, okay, and radium. Okay, so these are the second, that is second A group. Okay, second A group. Now this group have 2 electrons in their valence shell, that is 2 valence electron. Okay, what are valence electrons? Valence electrons are those electrons which are present in the outermost energy level of an atom. Okay, these electrons are called as valence electron. Now this second A group contain 2 valence electron. Now, and that's why they like to form ions with +2 charge. Okay, like this, they form ions with +2 charges. Okay, now next, these second A group is called as alkaline earth metals. Alkaline earth metals. Okay, now these alkaline earth metals are also reactive. Okay, these are reactive metals, but they don't react as violently as alkali metals. Okay, so here I am writing, but they don't react as violently as alkali metals. Okay, next, so this is about the second A group. Next we have, okay, after potassium and calcium we have transition metals. Okay, that is scandium, titanium, okay, vanadium, chromium, manganese, okay, iron, cobalt, nickel. Okay, so these are the transition metals. Okay, so here let's say I'm writing from here, potassium we have, next we have calcium. Okay, so next scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Okay, so these elements you have to remember. Now below zinc we have cadmium and mercury, these also you have to remember. Below copper we have silver and gold. Below nickel we have palladium and platinum. Okay, these elements you have to remember. These are the transition metals. Now these transition metals have variable oxidation state. Okay, variable oxidation state. For example, let's say this iron can form ions with +2 charges like F +2, or it can also form Fe +3, that is this ion is called as ferrous ion and this ion is called as ferric ion. Okay, next let's say we have copper can also form cuprous ion and cupric ion. Okay, so these transition metals have variable oxidation state. For example, cobalt can form ions with +2 charge or +3 charge like this. Next, chromium can have variable oxidation state from +2 to +6. Okay, manganese can have variable oxidation state from +2 to +7. Okay, so these are the variable oxidation state which are shown by transition metals. Okay, next we have, let's say, 13th group, that is boron, aluminum, gallium, indium and thallium. Okay, so these are the 13th group elements. Okay, and these elements have 3 electrons in their valence shell. Okay, that is 3 valence electrons, and that's why they like to form ions with +3 charges. Okay, so boron +3, aluminum +3, like this, +3 charges. Okay, the bottom elements can have variable oxidation state from like +1 to +3. Okay, like this, +1 to +3. So this is about the third A, that is 13th group. It is also called as, in Roman number it is called as third A group. Okay, next we have fourth A group, that is 14th element. Okay, it is carbon family, that is carbon. Next we have silicon, next germanium, next tin and lead. Okay, now here you have to remember just 2 elements here. Silicon can show +2 and +4 oxidation state. Okay, these 2 are main metalloids in the periodic table. Okay, silicon and germanium are the metalloids. Next we have 5th A, that is nitrogen family. Nitrogen family we have nitrogen, phosphorus, arsenic, antimony and bismuth. Okay, so these are the 5th A, that means 15th group elements. Okay, now nitrogen like to form ions with -3 charge. Okay, so this is the oxidation state of nitrogen and phosphorus that you have to remember. Next we have 6th A, that is oxygen family. Okay, so here oxygen, sulfur, selenium, tellurium, okay, and this element. Okay, so you have to remember these elements. Next, oxygen like to form ions with -2 charges and sulfur also, so remember these ions. Next we have 7th A group, that is halogen family. Okay, these halogens are very important: fluorine, chlorine, bromine and iodine. Okay, now these halogens like to form ions with -1 charges like this. Okay, now this 4th A group have 4 valence electron. Okay, 4 valence electron. Next 5th A group have 5 valence electrons. Okay, 6th A group have 6 valence electrons in their outermost shell. and 7th A group have 7 electrons in their valence shell. Okay, next we have, okay, so here 7 electrons in their valence shell, and last we have 0 group element, that is, okay, 0 group element or 18th group element, 18th group. Okay, so here we have helium, neon, argon, krypton, xenon. Okay, so these are the elements which are present in the 0 group. Okay, and these are the elements which do not participate in any chemical reaction. Okay, these are very stable. Okay, very stable elements. These are stable. Okay, inert, that means they do not react. Okay, not that reactive, not reactive elements. Okay, next there are some important points. Halogens are the most reactive non-metals. Halogens are the most reactive non-metals. Okay, so you have to remember here fluorine and francium. Okay, fluorine is the most reactive non-metal, and francium is the most reactive metal. Okay, so here most reactive metal is francium. Next, now metals like to lose electrons, that's why they are good reducing agents. Okay, so here metals, we have metals, let's say metals. Okay, for example we have sodium. Now you know that sodium have total sodium, the atomic number of sodium is 11, so here 1, okay, next, so here sodium have total 11 electrons and 1 electron in its valence shell. Okay, so this sodium metal likes to lose electron. Okay, like this, it lose electrons to form sodium, that is Na plus ion. Okay, now non-metals like fluorine. Okay, fluorine have total 7 electrons in their outermost shell, that is 7 valence electron. Okay, now this non-metal like to gain electrons. Okay, so it gain electron and form stable fluorine minus ion. Okay, like this, fluorine minus ion. Okay, after addition of electron, minus charge develops, and after losing electron, positive charge develops. Okay, so here sodium loses electron to form sodium Na plus ion, and fluorine gains electron to form fluorine minus ion. Okay, next.